Hello, grade 7. Our lesson today is, about solve one-step multiplication and division inequalities with positive coefficients. And the lesson that's coming after this lesson is solve the same or has the same title, solve one-step multiplication and division inequalities with negative coefficients. So since there are two lessons having the same title, but taking in consideration the different signs, so actually changing the sign of the coefficients of the variable is very, very important. Actually, it could change the whole the whole solution for, or changing the whole graph for inequalities. So it's very important for you to understand, the difference between graphing or dealing with inequalities with negative coefficients and, positive coefficients. Now, at the end of the lesson, you will be able to solve and graph one-step multiplication and division inequalities with positive coefficients. Now, what is a coefficient? Actually, when I'm saying, when you hear the word coefficients, it looks, let's look at this example. 2x minus 3 is more than or equal to 5. Now, I have here three numbers, 2 and 3 and 5. Actually, 3 and 5, they are constants since they are not multiplying by any variable. Now, 2 here is the coefficient. This is the coefficient. It's the factor. It's the factor that is multiplying by the variable. These coefficients could be positive and could be negative. Now, we will learn today, inshallah, the difference between them. But let's first talking about solving multiplication inequality by using, I can solve or you can solve multiplication inequalities by using the division property of inequality. As we said, same family, division and multiplication are actually same family. You can solve division inequalities by using multiplication property of inequality. So if I have actually a number that is multiplying by the variable and I want to, to isolate the variable, I will use the inverse of operation of multiplying, which is division. And, if I have the opposite, a number that is the variable divided by it, and I want to get rid of it, I will multiply the whole inequality by this number to get rid of it. And actually, the table will explain more what I'm talking about. Now, as we said, inequality remains true when you divide or multiply each side of the inequality by the same positive number. And this is what we said it, if you remember, we said the same when we were solving, addition and subtraction. Whatever you do as a change for the right side of the inequality sign, you have to do it as it, the same to the left side to keep the inequality true. Now, for all of the numbers, as they say, A, B, and C, if A is more than B, and then you divide A by C, you have to divide B by C to, keep the inequality true. And if you multiply A times C, you have to multiply B times C so that you will keep the inequality true. And the same thing, if it's less than B, A is less than B, and you divide or multiply by the same quantity, you should do that for the both sides of the inequality. Now, for example, 9 is less than 15. To keep this inequality true, where the right side is more than the left side, or the left side is less than the right side, whatever you do to the right side, you should do the same to the left side. You divide 15 by 3, you have to divide 9 by 3. Now, and you will do the same. As you can see here, if 10 is more than 7 and you want to keep it as, the left side is more than the right side, so whatever you do, multiply 10 by 2, you must multiply 7 by 2 to keep the inequality true. Now, the division property of inequality states that they repeat actually the same thing if A is more than B or A is less than B. Whatever you do to A, divide or multiply by a quantity, you have to do the same for B to keep the inequality true. Now, in example 1, they ask us to solve and graph multiplication inequality. 8x is less than or equal to 40. As you can see here, coefficient of x is 8. Now, and actually, as you can see, it's positive 8. So I want to solve it. To solve this inequality, I will isolate x and keep it alone to the left side by dividing by number 8. Now I will divide both sides to keep the inequality true. So 8x dividing by 8, it must be equal to, as you can see here, 40 dividing by 8. Now 8 or x over 8, you can notice that 8 will be crossed out with 8. Now x is less than or equal to 40 over 8, which is equal to 5, and this is the inequality. I solve it. Since x is isolated and it's less than or equal to 5, so I have only to graph it. How to graph it? Now, if you remember, now to graph it actually, you have to here to graph it, I will graph or draw the number line, and in the middle of it I will put number 5, and as we said, x is less than or equal to 5. Now I will draw a circle and fill it or closed it. Why? Because actually, as you can see here, there is less than or equal, and since all of the solution is all of the real numbers that are less than or equal to 5, so the solution is going to the left side. The solution is going to the left side. Now, I have to make sure that my solution is correct, so I have to check how by replacing, x by 4 in graphing the inequality. So 8 times 4, for example, if you choose 4, which is less than 5, so for 8 times 4, it's 32. Is 32 less than or equal to 40? Yes, so the inequality is, true. Now, they regraph it here, or actually it's graphed here. The inequality solution is less than or equal to number 5, and the 5 is a solution, because if you write, it's actually 8 times 5 will be 40, and 40 is less than or equal to 40, which is true since there is an equal under less than. In example 2, we will solve division, inequality. D over 2 is more than 7. Now I want to solve it. As you can see here, according to the multiplication property of inequality, so I will multiply both sides here by number 2. Now here I will multiply by 2, and I will multiply the other side, 7 by 2. Now 2 will be crossed out with number 2, so D is more than 2 times 7 equals to 14. As you can see here, D is more than 14. Now, how to graph it? To graph it, I will look at the number line. It's not necessarily to put all of the numbers or some of the numbers on the number line. Number 14, which is the solution of the inequality, is enough. Since the solution here is D is more than 14, just I can put in the middle of the number line number 14. Then, since there is no equal sign under more than, so I will graph a circle, empty circle, or actually it's not filled, it's open circle. And the solution that D is more, so D to the right More, it means to the right of the number. Left, it means, less than the numbers. All of the real numbers that are less than the number, it means that the solution line will be to the left. When I say D is more than 14, so all of the real numbers here that are more than 14 is actually a solution, and as you can see here, they go to infinity. Now, this is the whole lesson. I hope you understand it, and we will solve more problems in the class.